All right, today we are going to go through part one of Calc Lite, which is um, how we get uh, velocity and acceleration from position using calculus. So if acceleration is constant, then something like a is equal to 4 meters per second is true for all times. It would be a straight line on the VT graph, and you can use your kinematics equations in order to find v and a and anything else you want to find. But what if acceleration isn't constant? And this definitely happens. So if we had an acceleration that depended on what time it was, in other words, that a is a function of time. So an example would be a is equal to 2t, or a is equal to 4t squared minus 2t. You would get a curvy VT graph, and you can't use these equations anymore. So what do we do? Well, we use calculus. So excuse me, I consider this Calc Lite because I'm going to jump to the punchline, the rule you can use without really going through much of the why this works. So in calculus class, you need to do all the stuff your calculus teacher tells you because they tell you why this works. The good news is that you'll be able to check your work long before everybody else because you already know the punchline. So if we were going to find the speed at t equals 3 seconds of our position time graph, at this point, we would go ahead and find the slope. And you can do that a little more easily by drawing a tangent line to that slope that just follows the line right at that point longer so that we have more points so we can find the slope. So use rise over run and figure out what the speed is right at that point. So the slope of our position time graph, that is the speed. And we've looked at that before. But now let's say that we want to know the average velocity over a really small interval, we get an instantaneous velocity. So this is equivalent, this slope of that little teeny tiny point is equivalent to taking the derivative at that point. And that's what we call it. It's like the slope of the little teeny section of graph. Same thing is true of acceleration. If we take the slope of the little teeny section of graph right here, then that gives us the acceleration. We know that the acceleration of a VT graph is acceleration. So if we take the derivative of this graph, then we're finding the slope at all the points. And I'll give you more explanation in a little bit. So how do we do this? The act of finding the slope tangent to a curve is called differentiation, or finding the derivative. The result, which is the slope of the tangent line, is called the derivative, and it gives you a function. And there we go. All right, so if we take the derivative of the function of x with respect to x, that's what this means, then basically what we're doing is we're taking the slope, where this is the rise and this is the run, of every single point on the graph. And the way you do that is called power rule. And so this is your function, this is your f of x, is a constant k times x to the nth power. You multiply your x and your k by the power, so you take the n times kx, and then you reduce the power by 1. And your AP sheet gives the same thing on there. It says d dx of x of n is equal to n x to the n minus 1. So this is on the back of your AP sheet. It's on the side with the calculus stuff. So it's not on the side with the equation sheets, but it is there. So you can take a look at that. So let's do an example. We're moving so that our position is given by 3t to the 4th. We want to find velocity and acceleration. So velocity is the slope of position, or the derivative of position curve, and has to be take the derivative of x with respect to t. So we have 3t to the 4th. We're going to multiply by 4, so that's 4 times 3, and then we're going to reduce the power by 1. So it's going to give us 12t to the 3rd. That gives us the speed at any time t. That's the really nice thing about the derivative, is we don't need to keep finding a bunch of slopes. We find a function for velocity so that we can plug in for any time. Acceleration, is then the slope of velocity. So we take the derivative of this velocity function. So the derivative of speed with respect to time, we're going to again use power rule. So we're going to take the 3, multiply it by the 12, and then reduce the power by 1. So that'll give us 36 t squared. So once you get the hang of this, this isn't too bad. All right, suppose that we have a polynomial where we have multiple sections. So a g of x and an h of x, this is just a fancy way of saying there's 2 terms. So let's say we have x is equal to 3t squared plus 4t cubed. What you do is you find the derivative of each part. So you find the derivative here, so that's 2 times 3t, and then we reduce the power by 1. And then 4 times 3, the 3 times 4, and then t, and reduce the power by 1, and then you're done. So you just basically take the derivatives of the parts and add them together or minus them. It doesn't work for products. That is more complicated. So as a summary, slope finds you the velocity or acceleration at one time. So you use rise over run, or if you have a constant graph, it'll tell you the speed of that constant function. The derivative gives you a function for v or a that you can use to calculate for any time.